All right, so hello everybody. My name is Mike. I build distributed systems for fun and living, but I'm also a Java developer. And that's why today I would like to talk about the unknown parts of the JUnit 5 library. And you may ask, well, unknown? How is it possible that such a popular thing as JUnit 5, so something that is like in almost every Java project out there, can still have any unknown parts? In fact, it has been released around 5 years ago. So of course there were some changes in the meantime, but it's definitely not a new thing anymore. So what's the problem? What's the reason that we have those unknown parts? Is there something wrong with the project documentation? Well, in order to answer that, I've went through the whole JUnit 5 user guide. And you know what? You should do it too. It's awesome. It's really great stuff. It's full of very pragmatic and practical examples of the things that you could use to improve your testing almost immediately. So the world would be much better place, the code will be much better place if we would only read all these fantastic manuals out there. But for some reason it seems not to be the case. And maybe that's good, because the people like me have an excuse to appear on a conference like we are attending today. So what I would like to talk about. Let me start from the things that I don't want to talk about. So I don't want to focus too much on the JUnit 5 modular design, comparing the new and renamed annotations, or why the built-in set of assertions is still not good enough for me. Instead, I would like to show you some really practical stuff, so the things I consider useful in my everyday coding. Starting from some creative or unknown ways of parameterizing your tests, including writing data table tests, similarly to what you may know from libraries like Spock. We'll scratch the surface of customizing test case names. Then I will share a few words about how you can avoid test code duplication, but without introducing inheritance. And last but not least, I will show you my proposal of a pragmatic approach for test parallelization. So let's go, show us the code. Let's start from the first topic. So for those new ways of parameterizing our tests. And in fact, instead of slides, I will jump to code because I prepared a few examples for you. Imagine that we have a very simple pricing engine in place. So this pricing engine is actually expected to calculate the price. So the price itself is just a named amount of money. And apart from, or instead of some just simple subtraction on one amount from another, we have some business rules, additional business rules in place. So we have to apply a discount that is part of the marketing campaign on this regular price. And what's even more, there are some edge cases that we have to cover. So for example, if the discounted amount would be really small, like 0, or even if the discount is higher than the regular price, we should not give the item for free, but rather fall back to some minimal value, because in some territories it might be, from tax perspective, required to actually not give something for free, but for a very little amount of money that is almost, we will feel it like it was a free item or almost free item. So with such a pricing calculator in place, we could write some very simple test cases. And in many, normally those test cases will look more or less like that. We'll have one for applying a discount to a regular price. We could have another to test that we are falling back to this minimal price when the discount is full, which means that the discount is actually the same amount as the regular price. And the third one, when we will want to fall back to this minimal price, but when the discount is actually greater than regular price. So we want to avoid the situation when we are not only giving something for free, but even paying the customer for something. And of course, there is absolutely nothing wrong with these tests. However, we can do better because we have a lot of structural duplication here. So what do I mean by that? Just take a look at all the 3 test cases. We first set up the price, so the regular amount, then we are setting up the discount, then passing both to the calculator and then comparing the result with the expected amount. So we are doing 3 different checks, but exactly in the same way. And that's exactly the scenario for which the parameterized tests were introduced. So with parameterized tests, what we could do is to create a single test case and provide the expected input and outputs somehow. And in this case, I will use a feature called the method source when we declare a dedicated method that returns us a set of arguments for every single test execution. So we are returning here a stream of a dedicated type called arguments, and this arguments type is a built-in wrapper that could basically accept anything that we will pass into it. So if we'll run this test, you will see that everything's fine, everything runs smoothly, but still there are a few things that could be improved. So for example, this arguments type. One of the main problem with it is that it does not provide enough type safety. What do I mean by that? So if I will forget about one of the parameters, the test still compiles, but I will figure out that something is wrong while trying to actually run it. So how we can improve that? Well, one very simple way of improvement would be to move away from this argument type and use our own wrapper type. So in this case, it's a perfect use case for using Java records. So we could create a record like this one, like this pricing test case, where we will have all the parameters we are expecting, and then simply accept such a wrapper type as the only parameter to our parameterized test. So far, so good. Like, we solved the problem of the type safety. Now, there is one thing that we've lost comparing to the original implementation. So originally we had these nice names for the test cases, and right now, if we'll jump back to our parameterized test, this seems not to be the case anymore. So it's not that nice, although we are still able to figure out what each test is actually doing. But this is kind of boring. So it's quite similar to what you may already have seen with JUnit 4. So it's definitely not something you came here today. So let me show you a very different way of writing such a parameterized test. Instead of providing a method, we could use a feature called CSV source. And with CSV source, we are expected to provide the test input as a comma-separated values. So in this case, each line is representing separate test case where those values are actually the values of the arguments that we are expecting, separated by a comma. Surprise, surprise. Now, the nice thing about this approach is that we don't need a dedicated method anymore. We don't need this dedicated type, but as you may see both in the code and in the test case output, there are at least a few things that we could improve here. So let me show you what we can do. So in this case, I have 3 readability improvements and 1 magic trick for you. Let's start from those small readability improvements. Well, one thing that we could do is to replace the comma with something else, which is not that unusual when dealing with a comma-separated values, or the CSV format. So what I will introduce is a parameter called delimiter, and let's say that I will use a pipe character instead of a comma. So I could easily replace comma with pipe, which for some people, including myself, may feel a little bit more readable. And yeah, the test still passes, so nothing has really changed. Now, what we could do too, as the second step, I would apply some white spaces here and there, just to format the input in a little bit more readable way. The reason why we can do it is that because the JUnit is smart enough to actually ignore the leading and trailing white spaces in the CSV source, and this could be pretty useful while formatting our input. Now, what we could do next, so If we are not using a really ancient version of Java, there is another way of declaring the CSV input. So we could use a text block, and the text blocks are this new Java thing that allows us to declare the multi-line strings and avoid some stuff like, for example, additional quoting of the values. So what I could do here is for sure to get rid of those characters, of course, get rid of the comma, and the test should still pass as before. So far, so good. So as you can see, we've already improved the readability a bit. Now time for a magic trick. So as you may see, we are here expecting both arguments to be strings. So we then are converting them to the amounts. However, the JUnit is smart enough to do it for us, just because the amount type exposes a static factory accepting only the string. So with this in mind, we could simply change the type, the declared type of our input into the amount type and get rid of the amount creation. So if everything will go okay, sorry, the JUnit will basically handle the type conversion for us. And let's see it in action. Oh, no, that's wrong shortcut, sorry. So as you can see, the test is still green and we got rid of this nasty string type. So what next? Well, one thing that we could do is to actually improve the readability of the test input itself. So one thing that I'm missing here are the names of those parameters. So I would like to know what each column really means. And of course, I can figure it out based on the parameters that we have on the right side, but maybe I could simply put this information somewhere in the input. And in fact, I can, because the CSV source annotation supports something which is also known in a CSV file. So the headers. So we could start the special first row, starting from a hash symbol, and put some additional labels for the values we have here. And of course, we probably have to format our test input a little bit more. And once we will run the test again, we should see that the first row has been ignored. So far, so good. So now we have the information about the type of input parameters within the input itself. Now, what next? So one thing that we could do more would be to try to address the problem that I mentioned a little bit earlier. So the information about the description of the test case that is lost basically in the test output. So what we could do is we could add yet another column called description and just have this description directly in the test input. However, once we will run this test, you will see that nothing has really changed. So this is only the way of documenting the code, but not really changing anything in terms of the test output. However, there is a way to solve that. And JUnit 5 comes with this beautiful solution called display name. So with display name annotation, we are able to override this default test name and put anything we want. So we could have such a nice and business-oriented string directly in the test output. So no more those ugly underscores and things like that. Now, but how could we introduce this approach to our parameterized tests? Let me show you. So first, what we have to do is to still keep the description within the input source, but now we have to somehow reference it to use it within the test case name. How to do it? Well, we can start from applying the display name annotation just like before. However, with parameterized test, this display name annotation will be used as a kind of prefix for the names of all the test cases that we will have. But what we need is actually a suffix that will fall back to this value of the description column. And this is something that we could do with the name parameter of the parameterized test annotation. This name parameter accepts a string with various different placeholders. So it's a very simple templating engine. And what I will do here is to use an index of the test, so the number of test case starting from 0, and the value of the third parameter, which is, surprise, surprise, the description itself. And as you can see, we then end up with this very nice output of the test execution. However, there's one small drawback of this approach. So as you can see, this description has to be declared as a parameter to the test method, even if it's not used anything else. This is just a small price that we have to pay for better test case names. Okay, so as you can see, we already have our data table test. Let's see another ways of doing this kind of testing. Let's imagine that we are supposed to provide an encoder of a duration. So we have a duration in seconds, and we are expected to encode it according to some ISO standard. So the perfect way of writing such a test case is, of course, to use the CSV source annotation. And please note that in this case, the header does not start from hash, and this is not by mistake. If we'll run this test, we will see that everything still passes. But what's even more interesting, the names of the columns are actually being appended to the report from test execution. And this is thanks to the parameter called use headers in display name. Now, there is absolutely nothing wrong with this test, but when we are dealing with encoding, mapping, on this kind of translating, it might be beneficial to emphasize that we are mapping, so turning one value into another. The way we could do it is to replace delimiter with something called delimiter string. So the delimiter string allows us to actually use not a single character as we had before as a delimiter, but we can use any string we want. So for example, I could introduce this nice arrow that I've made on my own. And as you can see, the test still passes. Of course, there is absolutely nothing preventing you from going into more fancy ways of those delimiters. So for example, what we could do is we could try to change this value, so replace the arrow with a string like encoded as. And once we will do it and run test, you will see that the test still passes. And what we gained from that is something that is more readable or more human readable, which is always a good thing. Now, there are a lot of different things that you could do with your test input, like including number formatting or even putting additional single quotes if you feel that it's beneficial to do so. But one problem that we still had to solve is that in our test report, test execution report, we don't see this delimiter anything inside. And unfortunately, the only way of doing so is to repeat it again using the parameterized test name parameter. So if we would provide a template like the one you see on my screen, we could end up with a report containing the same output as the input we just declared within the CSV source annotation, but it's just a little bit more work to be done. Now, summing up, so the CSV source is extremely powerful tool, even if it's a bit underestimated. And of course, it's not that comma-separated value after all, but still, we can do a really cool stuff with it. Now, you may have noticed that the JUnit 5 has been built around the parameterization concept. So it's even, we could say that it encourages us to parameterize our tests. But of course, we have to be creative. So sometimes knowing that that we could use, for example, any delimiter we want is not enough, because we have to come up with something that is actually right for the context that we are working in. And of course, there is more. So we don't have enough time to cover things like parameterizing tests with enum values, or even writing very dynamic tests or test factories with JUnit 5. But it's all possible. So if you are interested, just take a look at the official user guide that I mentioned before. Okay, time for the second topic, so avoiding inheritance in our test code. And again, I have a few examples just for this purpose. So let's imagine the following case. There is a REST API. There's a remote service basically somewhere, and this service exposes a single endpoint called foo, and this foo endpoint is expected to return a string anytime called. So we created a very simple HTTP client, and by the way, this is the Java's built-in HTTP client. And once we have such a client in place, we would probably want to test it somehow. So how we could do it? One way of doing so would be to use a library like WireMock. So what WireMock does is the following way. So we are setting up a fake server on some port, whatever, and then we can use WireMock as a mock of our remote server. So what we will do is we will create our client, but providing the WireMock URL as the parameter, and then on the WireMock instance, we will say whenever somebody will hit /foo, let's respond with a string bar, and then with such rules in place, what we could do is simply call our client, so call the WireMock, and then verify whether the value is the same as the one we've just set before. You probably noticed that I've ignored quite a long piece of code. So we need some boilerplate around it. And that's because the WireMock server has to be started before all our tests. Then we have to reset it before each of the tests, which means we have to clear whatever rules were already saved. And at the very end, we have to stop the server once nobody else is using it. Now, it may not be a problem in such a very simple scenario, but usually we'll have more test cases requiring WireMock. We'll have more tests relying on WireMock. So we don't want to repeat this section on and on again. So how to do it? A straightforward solution, and something that I've seen in a lot of code bases, would be to keep the test case as it was in our test class, but move all this boilerplate code into some base test class like this one, so base WireMock test. And of course, there's absolutely nothing wrong technically with this solution because it works and it allows us to share this configuration across multiple different test cases. But using such an approach has one serious limitation, and it's related to the fact that we are allowed to extend only one class at a time. Why this is a problem? So usually, the WireMock will be only one thing that you would like to have in your test code base. You may need a database, or you may need a message broker. So for each one of them, you will quickly end up with such a base test class. Now, the real struggle will start once you will need both at the same time. So for every combination that you will have to and that you would like to support, you will most probably need yet another base class like base WireMock and database test, and so on and so on. So from the maintenance point of view, it's a mess, it's a nightmare. You probably don't want to do it. So what's the better way? Well, we can take all the code that we already have in our base WireMock class and move it elsewhere. And I've moved it into yet another class. But in this case, this class implements 3 interfaces coming from the JUnit 5. So the first one is called before all callback, and this before all callback gives us a function called before all. We have before each callback for function before each, and after all callback for after all function. These functions are exactly the same, or are the reflections of these annotated methods that we had before. So what we are doing here is we are declaring some actions that should happen on the test lifecycle. So of course we have to set up the WireMock as before. And now once we have this class in place, and please note this is not an abstract class anymore, we should somehow apply it on our test case. How to do it? There is a dedicated annotation for that called extend with. So yes, what you just seen is a valid JUnit 5 extension. It's as simple as declaring this one class and putting extend with on top. Why is this so important or so powerful? Well, the main reason is that we can extend as many, we can have as many extensions of this on the same test case as we want. So we are not no longer limited with the inheritance limitations. However, one thing is not as good as it may be. So we still have to get the wiremock instance in order to find its URL. And right now this happens through a static method, which is a bit weird because like the test itself should not know anything about the extension. Luckily, the JUnit 5 allows us to do it better. So one way of doing so would be to inject the wiremock instance into the test case. So let's run this test and you will see that the wiremock instance is still there because this test still passes, but now it somehow comes from the extension. How is that possible? Let's jump into the implementation. So the main difference between the two versions that you just seen is yet another interface that we are implementing called parameter resolver. And this parameter resolver thing comes with two additional methods. One is called supports parameter, and the second one is called resolve parameter. So with JUnit 5, we are able to set up a very simple dependency injection. So the first method is actually filtering by the type of the parameter of the test case. So in this case, we are saying that we are interested only in the instances of type wiremock server class. And then the resolve parameter part is actually expected to return the certain value. So in this case, return the wiremock server. But this is not the only flavor of test code application that we have to deal every day. So let's jump into yet another example. Let's imagine that we are building some kind of online game, and as in many games out there, every game has a map, and the map has, of course, its name and a level of difficulty represented as a number. Of course, the map itself is not enough. We also need a player, and the player also has a name and again will have a number, but in this case indicating its rank, its experience level. Now, it might be useful from the business perspective to be able to compare the players or compare the maps based on their rank or their difficulty. So the best way of doing so would be to implement the comparable interface. So that's why we have the compare to methods on both of the types. Now, you probably know that historically, writing comparators in Java was not a very easy task. And in fact, it could be a little bit error prone just because we are returning int here. Especially before we had those nice integer compare methods. So how we could test this comparable contract, but do so only once. So we would like to test the classes like GameApp, like player, only once, like define the very high level contract of comparable interface, and do not duplicate the test code itself. Well, another way of doing so would be to declare a test for every single entity, so for GameApp and for player, but to leave in this test no test methods, but only one method returning or building the test case data. So in this case, we need to provide three values. So the smallest value, the middle value, and the greatest value. So we are doing the same for maps and for the players. Now, if we'll run one of these tests, you will see that we have three test cases here. How is it possible? From where those test cases come from? And of course, the answer is they have to come somewhere from the comparable contract interface. Now, let's spend a moment to investigate its implementation. First, we have this generic test case representation. So we have a dedicated type, in this case, comparable test case, that expects those three values that I mentioned before. Then we have the test cases, our very generic test cases of this contract directly within the test interface. So the JUnit 5 allows you to use the Java default methods in the interface to implement the test cases. And those can be a regular test as well as the parameterized test we talked about before. So this way we could abstract away testing the certain contract, in this case called comparable, and just make sure that we won't have to repeat the same test code over and over again. Going back to slides. So as you may see, the extensions are extremely simple, and thanks to that, there is almost no need to use base test classes anymore. However, what about those tests as an interface thing? Well, in my point of view, it's definitely useful. It has its own good use cases, but I would be rather cautious about using it, especially trying not to overuse it too much. Last but not least, it's the time to talk about test parallelization. So whenever discussing the possibility of running our tests in parallel, we might think that parallelizing all of them at once is actually a good thing. However, it's often easier said than done. Especially if our project is already a few months or a few years old and we have a lot of test code in place, it might happen that parallelizing all of them at once will be more challenging than we expected, that there will be too many dependencies and not enough isolation. But does it mean that we are always forced into all or nothing decision? Well, luckily not, thanks to the JUnit 5's experimental API that I would like to show you today. So there is a dedicated execution annotation, and this annotation could be applied on both test class and test case level. What it does, it allows us to change the execution mode of this particular node in the test tree. So what does it mean? So by default, all of the things that we run are being run on the same thread. However, once we will put at execution on the test case level with execution mode concurrent, this test will now run concurrently to the rest of the stuff. However, in many cases, it's enough to use this annotation only on the test class level. So if we will do so, it will propagate down to all our test cases. So it means that not only our test class will be run in parallel to the others, but also all its test cases will be run in parallel. So this gives us a really nice opportunity to parallelize only what we want. But the question is, what we want to parallelize. And take a look at my test parallelization pyramid. So those standard 3 levels of testing differ in terms of the required effort and the expected performance boost. So starting from the bottom, the unit tests are the easiest one to be parallelized because there is they're really independent from each other. And because they are not using some shared state, they should be relatively easy to be run in parallel. However, going higher and higher in this pyramid shows us that although the boost is a lot more significant, but the effort required to parallelize, for example, end-to-end tests may be a lot bigger. So my proposal of the pragmatic way of parallelizing our tests look more or less like that. Let's start from the unit tests. So let's parallelize all the unit tests as default, because this is our low-hanging fruit in terms of parallelization. It shouldn't be a big deal to do so. But keep the rest, or allow parallelization of the rest of the test cases once they are ready. But one important thing here would be that we should keep the configuration of what should be run in parallel or what's not within the code itself. So how to do it? Let me jump into yet another example that I prepared for you. So we will start from JUnit 5 configuration file. And yes, you might be surprised, but there is such thing. So this JUnit platform properties files enables us to configure some JUnit parameters. In this case, we will start from enabling the parallel test execution. So what we have to do is to set this property, enable it, set it to true, but it doesn't change anything in terms of running tests in parallel yet. It only enables this, this feature. Now, what we would like to do is by default run things in parallel. We want to be the ones to decide, to run the things by default sequentially. We are the ones to decide what to run in parallel and what not. So with those two lines, we are actually saying keep running all the not annotated stuff on the same thread, so just as before. So this is the previous behavior. Now, if we'll have some tests that we would like to run sequentially, so just as before, there's absolutely nothing we have to do here. This is a typical test class with some typical test cases annotated with the test annotation. Nothing else needed. If we will run this test, you will see that we are running those test cases one by one. And that's exactly what was expected. Please note that in this case, every test case has this generated body with some artificial delay. So of course in normal life there won't be any artificial delay, but as you will see later on, it will just make things easier from the presentation perspective. So we have 3 such as sequential tests. Those are just very regular stuff, as I said before. Now it's time to see how the parallelizable tests look like. And the only difference between this sequential and parallel test is actually the presence of an annotation called parallelizable test. But this is not a JUnit annotation. This is a wrapper that I've just created for the purposes of this project. And this wrapper has in fact few interesting properties. So first, it enables the concurrent execution on the test class level. As I said, it propagates down to all the test cases we have. But instead of contrary to what was there for the original execution annotation, we are now limiting its applicability only to the types, so only to the test classes. So this way, it prevents us from overusing this annotation or using it in many places where it's not really needed. Also, another thing is that we explicitly say that we want a special test instance lifecycle type, which is called per method. What does it mean? So you may not know, but JUnit 5 decided to create a test class instance for each test method separately. So we are not changing this behavior here, but rather saying that we want it explicitly, just because this improves the isolation and makes test parallelization a little bit easier. So if we'll run one of the parallel tests, you will see, and let me run it again, that they are all running in parallel, which is exactly what we wanted. Now it's the time to take a look. How does it look when running everything at once? So I've used Maven to run my test cases, and let me maybe make it a little bit bigger. And start here. So every test case is actually leaving us with a log whenever it starts and ends, together with the thread that is being run on. So as you can see, we started at the very beginning multiple different test cases, and they all started in a different on the different threads, which is exactly what we expected. Now you might be surprised that the sequential test is actually also being run in parallel, but it's all good, because if we will see this thread, so this worker 1 is used only to run sequential tests. So the tests that are marked as sequential will be run one by one on the same thread. However, all the rest will be done in parallel. As you can see, the test took 6.5 seconds on my machine. Now let's disable the parallel execution, just to observe that, or we should expect that the tests will now run a bit longer than previously. So one thing that you could already spot is that every test is being run on the main thread. So we are running all of them one by one. And thanks to the very small hack with Maven, we can actually create such a toggle that could be useful in certain situations. All right, so this approach enables you to start small with an evolutionary approach, so avoiding this big bang of parallelizing all the things at once. But of course, we are still the ones to define those speed versus effort trade-offs. But still, thanks to the fact that we will start simple with parallelizing just the unit tests, making this first step should actually be pretty simple. And that's almost all that I have prepared for today. So if you want to play with the code that I've shown a little bit more, you can find both of the repositories on my GitHub account. So the first one covers first two topics, and the third one is only about this test parallelization. And in fact, some time ago, I wrote 2 articles about it, so you can visit my blog if you want to review it once more or get a little bit more details over how this works. And of course, if you have some time, please read the user guide. It's fantastic. It will change the way you're writing your tests right now with JUnit 5. And that's all from my side. If you will have any questions, I can try to answer them right now, or you can find me on Twitter to ask them. Thank you. And back to the studio.